delighted to announce our next speaker. We have the very eminent Dr. Michael, who is the lead scientist, yes, head of science and research at the No. 7 Beauty Cosmetics Company, or beauty company actually. And Dr. Mike is going to chat to us about skin changes with age, retinol, and future perspectives. I'm so interested, especially the into it. So, Dr. Mike, please come and welcome. Thank you so much. Thank you.
Thank you very much. It's a pleasure to be with you today. Thank you very much for inviting me to be with you and choosing to spend the next 45 minutes together. My talk's going to be a little bit eclectic because it's going to give you a flavour of some of the work that we've been doing with our research partners in skin. My kind of passion and relationship with skin has happened over the last 20-25 years, and I started off as a pharmacologist, and then I went into neurobiology and the brain. And then goodness knows how I found my way to skin. But I worked for a number of years with Procter & Gamble on Olay and Total Effects at the bench. And what I found wonderful about skin is that you see it, you can access it so much more easily than other organs, and you can see the impact that you can make on it as well. And really my job, I mean, I'm very lucky. I've got a wonderful job because it's very dynamic in what I do, but it's all about getting skin to reveal its secrets. That's what it's about. So we can do more to help skin actually perform better for longer. And, you know, that's why I love it, basically. So it is going to be a bit eclectic. I'm going to talk a bit about the No. 7 Beauty Company, just introduce it if you're not aware of it, you've not heard of who we are, how does it differ from No. 7. And I'm going to talk mainly about how skin changes through life, and I'm going to scratch the surface, okay? But it just hopefully will whet your appetite to come and understand more about it. And you understand lots about it anyway, so hopefully you'll come out knowing a little bit more, or, you know, wanting to know more about certain areas of research that we do. We're going to talk about diversity within that. It's so important. And again, we're starting off on our journey here. And you'll have Deja following, who's going to enlighten you more on that really important area for us. And then I'm going to talk about retinol more specifically. We've all got love-hate relationships with retinol. I'm no exception. And actually, we have not introduced retinol onto the market for a number of years. We've done it recently, and it's all about being able to do it responsibly, in my view. And then I'll finish with some of my own personal perspectives on where I think skin science is going to go in the next 5 years and where the key areas of focus are. So there's lots of slides, there's histology and bits and pieces of skin, but you'll love it, all right, hopefully. Well, the picture's better anyway. So first of all, just about the No. 7 Beauty Company. And really, this was about us trying to get our key skincare brands under one roof as the No. 7 Beauty Company with a shared vision and a shared purpose. And at the heart of the No. 7 Beauty Company is science, but it's also about affordable luxury, affordable beauty, so products that really work at prices that people can afford to pay. And also inclusivity is really key as well. So those three things. And actually our brands all have the same common values and purpose, so why not put them under the same banner, under the same roof? And actually, that's really important from a science point of view, because it means that all the science that we do from an education point of view, scientific insights, can fuel all these brands, and not just No. 7, which historically is what was happening. And to bring this to life a bit, I've got this 2-minute video.
Here comes the brand new. Here comes the brand Here
product better than I can. And we've just celebrated our first anniversary. So I think we launched in April of last year. So it's great, and it's working really well. We can be much more collective in what we do. Brands I'm sure you're familiar with under this one roof. So I'm going to take you back to 2007. And many of you will already have known about this and probably heard me speak about this till the cows come home. And if you haven't, it's really important for Number 7 and the Number 7 Beauty Company, because it is the time when we've really realised the importance of science and science research to help consumers pick one product versus another. And if you don't know the story, we had a product called Protect and Perfect Beauty Serum on the shelves, and we were going to delist it. It wasn't doing very well, and we were going to take it off the shelves. But it had a really unique aesthetic sensory feel about it. We knew it worked for those consumers who used it, and we approached the Manchester University at the time, and Professor Chris Griffiths, who's the Foundation Professor of Dermatology there, and we said, look, we really believe in our product, and we believe it works. Have you got a way of demonstrating how it works for us? And he had an accelerated repair methodology, which basically was a kind of biopsy patch test, where he applied products to photo age forearm, and then under a patch, and then basically in 2 weeks of usage, you can basically get 6 months worth of effect of repair effects. And he had pioneered that with tretinoin, so retinoic acid. So he said, I will try your product, be the first cosmetic product he's ever tried. It won't work, I can tell you, but I'll try it. And if you let me do that, let me write about it and publish it, even if it doesn't work. So we're going, really? I'm not sure about that. But we did have confidence in the product. So at the time, we decided to go for it, right? And the rest was history, because in this picture here, this is you're familiar with skin, so the pinker area is the epidermis at the top, and the whiter area is the dermis underneath. Now what we're looking for is black springs called fibrillin, which makes up the elastic components of the skin. This is 55-year-old skin, and in this skin there aren't any springs, because the springs have gone. They have been damaged, and they have been removed. So one of the precursors to lines and wrinkles. Now then when we put Protect and Perfect on it, look at that. Now, those are the beautiful candelabra fibrillin elastic springs that you have in young skin. And for the first time, a cosmetic product has been shown to repair structural elements of the skin. And, well, the rest was history, because the BBC wanted to do an independent programme for Horizon on what consumers have in their bathroom cabinets, and are the claims that products make, are they based on anything? And so there was a 3-minute bit on Protect and Perfect, because they approached the University of Manchester and said, what have you got? And they said, well, we've got something very exciting. They'd never be allowed to do it today. And what we had was pandemonium. After that aired in March 2007. We ran out of product. We ran out of a year's product in less than a week. We had queues around our booth stores. We had consumers fighting in our stores, if you remember, to get their hands on the last product. Behaviour was terrible. But what it said, and we then published it in the British Journal of Dermatology, but what it said was the importance of independent proof that your product, that your technology really works. And that was the way that we were able to cut through all the other products that were on the market at the time. And it was as simple as that. And you know, in that year, Number 7 at the time was really a colour cosmetics brand. But after that year, it became a science-driven skincare brand first and colour cosmetics second. So it changed because of that one moment. Now you can imagine that since then, all our directors have been saying, I need another Horizon moment. You know, not so easy to get that kind, you wouldn't get that kind of endorsement from the BBC now, right? They wouldn't be naming brands in that way. Now, of course, what that was the catalyst for a research programme with the University of Manchester, led by Professor Chris Griffiths, but also his amazing team. We've got Professor Rachel Watson, who leads on the clinical science, and we've got Dr. Mike Sherritt, who leads on the basic science. And we're now into our third 5-year collaboration. And it started off looking at mechanisms of skin aging. It's now much more about healthy aging, ethnicity, you name it, lots of different elements to it. And I can talk about it at length afterwards if you're interested in hearing more about it. And a team of about 17 people who we work with collaboratively at the bench, hand in hand. And I also just wanted to mention, I'm passionate about education, I really am, which is one of the reasons I'm here today, obviously. One thing that we're really proud of is that we recently had a grant application approved to work with the BPSRC, which will fund something called the Collaborative Training Partnership. And this is all about addressing the UK gaps in biosciences. So it's building biosciences capability, and it's also about the next generation of future brilliant scientists so that they can be trained to be entrepreneurial, trained in business, as well as trained in excellent scientific skills. And that's really important. So what they do from science has patient and consumer relevance. That's what we're trying to teach. And to try and, if you like, catalyse from research insight to innovation, technology, products, intervention. And that's what we need to do. So we're really excited about that, and it will allow us to work with other UK institutions as well. So very exciting. It starts in October. So let's get to ageing. And really, as I said, first of all, our work really focused on the mechanisms of skin aging. And of course, what we all realise is that it's a trajectory that we're all on. And actually, aging there are multiple factors. You know, we've got what happens in terms internally, our immune function, oxidative stress, whether we've got other diseases, our hormonal fluctuations. What we've also got is external factors, sun, pollution, noise to the aging or aging systemic being. And then we've got our lifestyle choices that we make, that we're going to go deliberately and sunbathe in Tenerife without any SPF. I used to do that. We used to do that. It's awful. With baby oil. Can you imagine doing that now? You know, no wonder I'm struggling with my skin now. But that's what we did. That's what we did. You wouldn't dream of going out without SPF now. Smoking and the effects that has, psychological stress, diet. And of course, all these factors accumulate over time. But then it's related to your susceptibility, your genetics. Why does somebody's skin, when they go out into the sun much more without SPF, look still so good, while somebody else's skin doesn't? It's about genetic susceptibility. And you know there are lots of kits out there where you can now take a swab, measure your genetics, and they come out with a prescribed regime for you. The reality is, genetics has only started to identify links to disease, let alone skin. So there's still the so what with all of that. Because until we find out what are the genes that really make you more susceptible to aging, to disease, or skin health issues, or skin barrier issues, only then will genetic tests really be meaningful, I think, in the world of skin. You know all this, I'm sure, but talking about skin aging, obviously we talk about an 80 to 90% of accelerated skin aging due to the sun. And this gives a very good example of that from the late 1990s. And this is somebody who'd been working out as a farmer for many, many years outside. And you can see this beautiful I say beautiful, I'm sure they don't think it's beautiful, but rhomboid, crisscross structure of lines and wrinkles on the back of the neck. And that is due to collagen degradation, principally, and something else I'll mention in a moment. And that is in contrast to the smooth, even skin tone, no lines and wrinkles, non-photo exposed area of the neck. Now, you can all do that. You can look at your arms and you look at areas which aren't exposed and you can see that difference. Now, if you look at the biopsy, so you go deep into the skin, on the right-hand side you have the area from the sun exposed, which is the bit at the top, and on the left, the smooth. And all you need to see is there's lots of black, isn't there? There's lots of black in that right-hand picture. That is something called elastosis. So that's when you're elastin, you have more elastin But like elastic bands, it bundles up into balls. So you know when you've made a beautiful ball out of elastic bands and you put it together, those single elastic bands are no longer functional. They don't work. And this is what happens with sun damage. You get elastosis. That means more elastic, but it's aggregated together, and so is no longer functional. And that is kind of what happens in accelerated aging. Now, I'm very passionate about UVA. All right, now, and really, we were doing some research to think about, a number of years ago, whether we should put high-level UVA protection into our anti-aging day creams on number 7. So we did a study, and there were studies around on single individuals where actually, if you think about people living behind glass and working behind glass for many, many years, do you see accelerated aging? And the reason for that is that UVA, 50% of it can pass through glass. UVB doesn't, okay? So UVA is more highly penetrating, but it's less energetic, so it penetrates deeper into the skin. But we thought, well, could we show the damage that UVA can make, or the contribution to aging, by trying to find people who either drive long distances, and have done for a number of years, are teachers in classrooms, or lorry drivers or taxi drivers, anything where you're standing by a window for many, many years. And we found tens and tens, we found over 100 women and men, when we did this in France, who had asymmetrical aging. And this particular lady is a French lady who is a saleswoman, and she drives 2 hours to work and 2 hours back from work, with the sun on this side, and then when she goes back, the sun is also on that side. And so you've got that cumulative UVA exposure, and you can see the lines and wrinkle increase that she has on that side of her face, and the pigmentation. And that is due to UVA. So the message is, use high-level UVA protection. 5-star, if you're number 7, or boots, is really, really important. And we published that research. Yes. Now, the other thing we've been founding at Manchester is, and you know, we observed, so therefore we wanted to do a study, that our parents and our grandparents didn't age in the same way. So everybody talks about lines and wrinkles, but actually I was looking at my mother and thinking, you don't have many lines and wrinkles. Your face and skin is really smooth. And yet you've actually been in the sun a lot and you've enjoyed sun exposure. And so actually we did a study, and it showed that actually there were 2 different types of aging. Now this is only in white skin. I don't know what happens in skin of different colours, and that's what we're going to find out. But in white skin, you have atrophic, smooth, which is more, it has blood vessel breakage, telangiectasia, things like that, and has a very different look, more like a translucency to it, versus hypertrophic, wrinkly skin. Now, interestingly, the smoother skin, atrophic, is more prone to skin cancers than the hypertrophic. Interestingly, men seem to be more atrophic than hypertrophic. But what it shows is that it's not all about lines and wrinkles. We don't all wrinkle. There must be a genetic reason for that, which we don't know yet. But we find it fascinating. So when we think about ethnicity, and Disha, as I say, will talk more about this, we have scratched the surface, right? We need to do much, much better at thinking about and understanding the wonderful diversity of skin. And that's not just in skin science, it's across medical profession and medical fields as well. So we've started to do some work, as I say, we're on a journey here, and this was a study we did where we looked at 200 to 300 white Caucasian, we looked at 200 to 300 Far East Asian, and 200 to 300 African Americans, and we had them in different age groups, and then we took their photos and we measured, did image analysis on those faces to see if we could compare lines and wrinkles or different aging features. And you can see they present very differently. They are all in their 70s, and they all have their unique exposures, unique lifestyles, and importantly, there's different amounts of melanin. Okay, and melanin is fundamental to protecting from the sun, the natural pigment protecting from the sun. Now this is one parameter, this is under eye wrinkles. And if you look at that, sorry if you don't like graphs, okay? For some people I know graphs make them feel sick. So with this graph, I love graphs, but with this graph we have age in the bottom, and all you need to know is actually Far East Asian and Caucasian light skin is showing the same kind of trajectory for under eye wrinkles. But you can see the delay for black skin, for African American skin, of maybe nearly 20 years in terms of the development of under eye wrinkles. But what you can see is it does get there eventually. It just takes longer. And the reason for that is almost certainly melanin. And just to dive a little bit deeper into melanin in a minute. Now, there are differences in the way they age. But what would be interesting is to take away the impact of sun and just look at what we call intrinsic aging. Now, for intrinsic aging, the best place to go to see skin that has not been exposed to the sun is the bottom. Now that's unless you like waving your bottom in the air and exposing it to the sun. But generally, the bottom is quite pristine, okay? So, at the University of Manchester, we've been studying bottoms. And we've been taking bottom biopsies. Bottom biopsies, I like that alliteration. And we've also been testing how the bottoms bounce. We've been testing the mechanical properties of the bottoms and trying to relate to what we see in the skin to how it bounces or how elastic it is. And on the left here, we've got, if you think about it, the blue is the epidermis, and underneath, you've got the dermis. But can you see that junction between the blue, that wavy junction? That's the dermal epidermal junction. And underneath it, you've got these hairs. Can you see these little hairs? That's those fibrillar springs that protect and perfect beauty serum repaired. Well, you can see there are more springs in the African bottom than there is in the white European or Caucasian bottom to begin with. And then when we measure the elastic properties of the bottoms, the African bottoms were more bouncy. Now, so what we kind of concluded from this is that actually the structural components of skin across different ethnicities is actually the same, right? It's made up of the same stuff, but there are different quantities of the different components, and that's clear. Now, the reason for that, we don't really know yet, but you can measure the more clinical and consumer relevance of some of those histological changes, the differences that we see, which I think is fascinating. Now, some work we did at King's College London. There is a myth out there that skin of colour doesn't require sunscreen because there's melanin to protect it. But actually, we did some work at King's College London to see if that was actually true. This is what we did is we took white Caucasian volunteers, but also black Nigerian volunteers, and we took them into the lab, and then we irradiated their skin, mimicking sun exposure that you get in summertime in the UK. And what we then did is took a biopsy, and we've looked at the DNA damage that you get. And this is white skin, and the epidermis is everything above the dashed white line. And all these highlighted green cells are where there's DNA damage. So not surprising, white skin doesn't have much melanin to protect it from the UV, so you get loads of DNA damage. Now, when you looked at black skin, what you found there is that halfway through the epidermis, you've got DNA damage. And then towards the bottom of the epidermis, you didn't. And that's because the melanin is concentrated in the bottom part of the epidermis. So where you've got that DNA damage is above the melanin. So the melanin can protect the deeper layers, but it can't protect those top layers of the epidermis, even in the darkest of skin. And what we know, and you all know, is where the skin barrier is and how important the skin barrier is to health. And those upper layers are basically differentiated cells that are producing that skin's barrier. So really important. So the nutshell of this is that actually you still get damage even in the darkest skin in the top layers of the skin. So sunscreen is really important. And often in darker skin, actually, skin cancers go less recognised, they go less diagnosed, and so they are more fatal when they get picked up, because there's an expectation that they won't get skin cancers. It's not true. And we published that relatively recently. Now, another place where we get epidermal changes is in the menopause. And we've recently published a study on the menopause, again with the University of Manchester, that is where we've taken a premenopausal group of women, a postmenopausal group of women in about the age of about 55, and then a postmenopausal group on HRT. And we've compared the skin. And what you can see here is actually that the epidermis is thicker in the pre and then gets thin in the post, so that there's a thinning of the blue layer, the epidermis, and there is a thickening, can you see, of the stratum corneum? That outer layer that's flaky, it gets thicker, but it gets more flaky. And then if you look at the post-menopause with HRT, it's recovering it back to where it was before. Now, we've since done studies to show that actually, during the menopause transition, ceramides are lost. So there's a reduction in the total amount of ceramides, and also there is an increase in how bad the barrier is. So it's linked to something that is clinically relevant, but again shows the importance of hormones, and in particular estrogen, and how it regulates this whole epidermal skin health, which is really fascinating. And there's loads of more research that we are going to be publishing quite soon in this area. So when we think about biological targets, it's a bit messy, this slide, but traditionally, this is what we look at, right? This is all the dermis. So we talk about collagens, we talk about elastin and fibrillins, and we talk about GAGs, glycosaminoglycans. Hyaluronic acid is a GAG, right? Creates volume, creates stuffing, binds moisture. And these are the kind of targets that we go after with our ingredients. But we also know that the epidermis, as we just talked about, is important. And at this point, I wanted just to talk about an area that has been around for a number of years, but I suppose not got a huge amount of traction in the name, but of course, a lot of the ingredients are what are trending now. And this is the area of cosmeceuticals. And cosmeceuticals really, as it's defined there, is this area of technology for which there is more established clinical proof, more proof than other ingredients. Having said that, it doesn't mean there's a lot of proof, right? And it is really a gap. And actually, there has to be much more work and transparency of how the technology is working and publishing that research from companies like ourselves, I would say. And these are the kinds of cosmeceuticals where there is more established clinical proof. Vitamin C, AHAs like glycolic acid, salicylic acid, azelaic acid, niacinamide, of course. Procter & Gamble have spent years researching niacinamide, and they're still researching niacinamide, vitamin B3. And if we look at Google searches over the last 5 years, we can see that they're trending upwards. This shows some of them. And they're all trending upwards. There's an interesting spike at around lockdown, which you can see, as everybody goes searching for the best cosmetic ingredients. And I wanted to touch more on retinol, because, as I said at the beginning, we all have a bit of a love-hate relationship with retinol. Now, retinol, I'm sure you know, comes from the fact that Kligman, when retinoic acid, or tretinoin, was being used for acne in the 1960s, he noticed that people on long-term tretinoin treatment started to look younger. Wouldn't that be amazing? It treats my acne and I'm rejuvenated at the same time. And that's what happened. And so suddenly there's this idea that tretinoin must be good for skin rejuvenation as well. And then in the 1980s that was clinically established. And tretinoin, as you can see here, it takes time to work, right? At least 16 weeks. So it doesn't happen immediately. And this is now the gold standard. Prescription, so it's a drug, treatment for photoaging, so sun-damaged skin, amongst dermatologists. but it has its issues because it's irritating, right? Causes photosensitivity. So obviously the search was what would be an alternative in the world of cosmetics. And that's where we come to a number of different vitamin A's, members of the retinoid family. So in cosmetic products, traditionally, we've always used retinol esters. Pro-retinol, we call it, because it gets converted into retinol. And we use retinol palmitate on number 7. Olay, I think, use retinol propionate, but it's the same stuff. It's an ester. And it's very stable, and it's very gentle. But it's not that efficacious compared to retinol and retinoic acid, because it needs converting, right? So what happens to pro-retinol in the skin? It gets converted into retinol, and then we know from retinol is much more unstable in formulation, so you have to be very much more careful with it. Light, you have to make sure it's packed under nitrogen, for example, so you can encapsulate it, and it's much more irritating than the pro-retinol, especially at certain concentrations, which we'll talk about in a minute. And then there's retinoic acid. So tretinoin, all trans retinoic acid, which is highly unstable and highly irritating. And traditionally now, I mean, they used to use 0.01% in dermatology. They now use 0.025%. So 0.1% they use, now they use 0.025%. And they get good efficacy with that whilst managing better the sensitivity and irritation. Now, interestingly, in the skin naturally uses vitamin A. It does, right? I mean, we know vitamin A is used in the eye, for example, in the retina, but in the skin it's also used. And from the diet, it's stored in the form of the pro-retinol. And when it's needed in skin cells, it gets converted into retinoic acid. So it's naturally present and doing a job in the skin. So don't worry about this, it's a bit busy and complex. I'll test you on it later. But the point is here is that this grey bit in the middle is at the nucleus where the DNA is, and that's a cell. And all you need to know is that the cell binds retinol. It binds retinoic acid, takes it in, and then it converts it into retinoic acid. And then retinoic acid acts at the gene level. It turns on more than 500 genes. So it's not going to have one effect, it will have multiple effects, okay? So it actually acts at the gene, the programming level of the cell. And this is an attempt at showing some of the diverse benefits of it. So if you just bear with us, what you can see is the one on the far left is collagen, and it's increasing collagen production. We're increasing proliferation. Oops, I'm just going to go back and do it again. There we go. Increasing proliferation on the top right, thickening of the epidermis, and then our fibrillin springs that it increases as well. All right? So multiple benefits. However, we say it's a cosmeceutical, and yet in the world of retinol that's been around for years, there's not an awful lot that's been published on it, to be honest. And knowing what the right concentration was of retinol that drives really good efficacy whilst minimizing irritation is really important to our consumers, isn't it? Because there is a trend towards just give as high a level of retinol as possible. Now that's irresponsible without truly understanding what it does and formulating for that. So we did another study with the University of Manchester, and it was a biopsy study. Again, we like biopsy studies, not on the bottom, don't worry, on sun-damaged skin. And here we go, untreated, and it's just stained the epidermis, right, which is blue. Now wait for it. 0.1% retinol. Look at that. Look at that thickening of the epidermis. And those pink cells are cells that are proliferating and producing baby cells. Right? So proliferation, renewal of those cells at the bottom of the epidermis. We go to 0.3%, and then we go to 1%. You can see massive epidermal thickening. So one of the key areas in which retinol will work more quickly is in the epidermis, not deeper down, right? And you can see that here very profoundly. Now, just to show you that magnified, so 0.3%, you could see from that, 0.3% was getting really good thickening of the epidermis and getting those epidermal changes. The question is how well tolerated is 0.3%? And can we look at them side by side, efficacy and tolerance? So we did a study back at Number 7 Beauty Company where we gave consumers either 0.5%, 0.3% or 1% retinol. And we ramped it up. I mean, you're all aware of the importance of ramping up retinol. So for people who've never used retinol, you start using it maybe twice a week, not on consecutive nights. You ramp up and you listen to your skin. You don't prescribe it. But in this study, we tried to get everybody to nightly use after 4 to 6 weeks of retinol. And what we then did with a dermatologist is we categorized the effects that they saw as either tolerant, so basically no side effects or just slight stinging, but easily managed. Managed, which meant they could keep going with the retinol. So what they might do is go, I need to step down on my usage, but if I do that, I can get through it, my skin can adapt. Or they stopped using the product because the reaction was too severe, so they couldn't continue. And what you can see by the numbers is that with 0.3%, we managed to get to 96% tolerated and managed the retinol with the right usage regime. So you use a night cream after, you use SPF protection, you don't use exfoliators, you ramp up gradually, all that great advice, which is really important. You can get the mass consumer to get great efficacy with 0.3%, but also tolerate it very well. Now, this is the kind of curve you get, another graph, I'm afraid. Retinol concentration at the bottom, and you can see efficacy and tolerance at the top. And the sweet spot for the mass consumer, who is not used to using retinol, for us was definitely 0.3%. That's not to say that there isn't value in 1%, in higher retinol, but you have to be careful how you use it. We would promote using a kind of product after, like a barrier product, more control over any inflammation and irritation, but it can drive benefits in more stubborn, more aged skin, for sure. Okay, now I just wanted to also touch on black skin and skin of colour and the effects of retinol and tretinoin. So we published a study quite recently with GHU, Johns Hopkins and Manchester, showing that in black skin you also get epidermal thickening, and you can see it here, and you get similar effects with tretinoin. We're doing those studies at the moment with retinol, and it looks very similar. So again, with skin of colour, we're seeing the benefits of retinol. So it's not just something that is going to be beneficial for white and lighter consumers. Now, when we look at the fibrillin, for example, you can see here again, on that right-hand side, you're even getting fibrillin production of those springs in the tretinoin-treated black skin. So again, benefits for the epidermis, but benefits deeper down as well in skin of colour. And we're going to, as I say, do that work on retinol as well. Now, of course, that's lovely. Biopsies are great, but what happens with retinol when you actually do a clinical study and you measure signs of wrinkles? And this was a study which we had two groups. One group was using a day cream, an anti-aging day cream and night cream, and the other group had the retinol serum of 0.3% added in on top in the night time. And you can see this is just under eye wrinkles shown, but 97% showed a clinical benefit for the retinol treatment group versus 45% on the control. So we can really see the benefit that it is driving, but I would say, if you really want to see the benefits of retinol, you need to use it longer term. You know, it's not a miracle instant fix, right? It works with the biology of the skin. And we all love our before and afters as well. And this was a particularly good responder, I would say. Okay, not an average responder, a good responder to the treatment. And you can see her skin is much more even skin tone, and her lines and wrinkles have improved. So to close with, really, I wanted to just give you some of my personal perspectives on where I think skin science is going. And there are a number of different areas I think that will be a focus. The first area that I think is that we traditionally have had a reductionist approach to science, and that means we study little things in a petri dish to do with one aspect of skin biology, and then we think it's the most relevant thing to all consumers and patients in the world. And really what we need is a much more systems biology approach. The skin is part of all the organs of the body and it communicates, it has a relationship. So the brain-skin axis and the role, for example, of cortisol and stress hormones on the skin, we all feel it, we know it happens. The gut-skin axis is a growing area as well, about the things that we eat and the impact on nutrition on skin as well. So we have to think about it in the context of the whole body. It makes it more complex and difficult to study, but it makes it more relevant. And with that in mind, what we have is omics and the world of omics. So everyone is fascinated by collagen, right? I'm sick and it's not sick and tired. But they always talk about collagen and say, oh, have you got collagen in your skin cream? Well, no. It's high molecular weight, it will never penetrate into my skin. But they're obsessed, the consumer is obsessed with collagen, so we have to educate. But actually, it's much more important to understand all the different pathways that our products that are influencing and what's happening in the skin. And this is where genomics, so the study of different genes that are expressed, proteomics, what proteins are expressed when we add retinol into the skin? Because collagen might be increased, but there might be something that might not be so nice increased, and you just happen to choose the things that are nice to show to everybody. We have to have a much more general approach to this, and a pathway approach. Now, all this data means we're going to have to get much better at machine learning, artificial intelligence. We hear the words everywhere, and the world of bioinformatics. We have to be able to handle all that data that's being generated, and we have to be able to turn it into something meaningful and predictive for work, because otherwise we're just going to get lost in data, right? So this is why actually in our program for new PhDs, bioinformatics and mathematical modelling is what we need in biosciences, right? So that they can do this kind of work. Diagnostics, well, my goodness. Even Boris can do lateral flow tests. And, you know, I didn't think that cell-based or biological assays would ever be done in the home. But they have, because we had to, didn't we? We had to do it. But maybe this there is the catalyst for us to be able to do other things. Consumers to do other things in their home. Take their own skin samples and put them in a kit and measure the oxidative stress in their skin, for example. The amount of inflammation in their skin. That's exciting, right? And of course, there's still this world. I mean, we've just launched our ProDerm scan. I think the team who's sitting here can, if you want to get a scan afterwards, it's there in the foyer. And this is going to help consumers choose the right products. This doesn't make a recommendation, as the team will tell you, but it's reliant on the beauty advisor's expertise to help talk through and educate the consumer about their skin so they can make the right choices in terms of products. And sustainability, well, Millie is talking about sustainability at the same time. I think it's huge, but in my world, you know, it's biotechnology and how we can get to green chemistry or blue chemistry and harnessing the power of plants and marine organisms to do it in a really sustainable way with good provenance, being really careful about the sources of ingredients that I use. And I'm nearly finished, click on. And inclusivity, of course, it's going to be a big, big thing that we have to get our heads around and do well. And when we say inclusivity, not just it be something we just say because we think it sounds good and it's trendy. We have to do the science to make sure that products are fit for everybody and it's not just a statement that hasn't got any substance behind it. Really important for us. And finally, as I've said, I'm passionate about it. It's why we're here today, education. We've recently launched Skin School. It's about upskilling our beauty advisors, but also our colleagues as well, our commercial teams, because it's no good them not understanding anything that I say to them. So it's really important that the skills are up. We do this and roll it out everywhere. And we have to be more transparent as an industry about what we do, the science behind it, the proof behind it, to help everybody choose the right products for them, ultimately. And that's it. Thank you very, very much. There's a big team back backup booths in Nottingham and teams in Manchester University as well, teams here who do a fantastic job. So thank you for that as well. Leslie, have we got any questions or what time?
Does anyone have any questions? Can I come on, Patrick? Sorry, can I ask you in your opinion with regards to retinol? Do you think we put too much emphasis on the percentage and less on like the delivery system or?
Yes.
Yeah.
I think so, because they have to go hand in hand, and actually there are different types of retinol. So some retinol is encapsulated, for example, some retinol is not. Actually, some retinols on the market are unstable. So what you'll see, if you measure the retinol levels, it won't be what's stated on the pack. So I think that's right. I think there is a level of retinol that is necessary to drive a benefit, that's for sure. But yeah, you have to look at the whole package. The delivery system is really critical to that. And in order to understand that, you have to get underneath it. What is it? What is the retinol? How is it made stable? Show me the data.
Thank you.
Oh,
Sorry, one more question. Yeah. Just from the consumer's point of understanding, if you had a retinol 1.5% complex but 0.3% pure retinol, what does that exactly mean?
it's a load of rubbish, isn't it? so it's not great, is it? So what that means is it's not. So 1.5% actually was a complex that included soothing ingredients, it included the encapsulation of the retinol, okay? But the reality of that is the consumer doesn't know what level of retinol they're getting. So it was a mistake. It was a mistake to do that, and it will be changed.
Right, okay.
Because what we need to be, I've just said it, right? Hands up, we were not good at that moment. Because, did somebody say about retinol level, driving for higher retinol levels? Well, the science tells you, you don't want to be sticking 1.5% on a pack and making consumers think it's 1.5%. And why do you need to do that? We've got all the science proof to show 0.3% is a brilliant sweet spot. So let's just be clear about that. So yes, it should be clearly 0.3% retinol, and that's what we should communicate to our consumers. And that is what we will be doing. Okay.
Thank you.
All right.
I think, Dr. you're going to be around, aren't you?
I'll be around.
Yes.
Yes.
If anyone has any more questions, please feel free. And a huge thank you.
You're welcome.
Dr.